Okay, so we're continuing on with the sequence party, and today we're going to talk about arithmetic sequences. So, what is an arithmetic sequence? So, it is a sequence where each term increases by a fixed constant called the common difference d. So, arithmetic is sounds like arithmetic, right? So, it's talking about a sequence where like the same number is being added over and over again. So it's easiest to talk about this with a couple of examples. So let's say I have the sequence 1, 2, 3, 4, 5. So you can tell that each term, right, is increasing by 1. So the common difference in this case would be 1. So how much it increases by. So when they say common difference, if I take 2 minus 1, the difference is 1. Now what about this sequence? So I've got negative 2, negative 4, negative 6, negative 8, negative 10. Well, in this case, each term the term increases, kind of weird to say increases, but we have this common difference of negative 2 in between them. So if I just keep subtracting 2, I'll get the next term. So that's the idea of an arithmetic sequence. It's that you're kind of either adding or subtracting the same number over and over again. Now, in general, we can calculate the common difference by taking one term minus the previous term. That's the easiest way to do it. So if I had something like, what is the common difference for negative 7, negative 5, negative 3, negative 1? So the way that you would do that is you would calculate the common difference. So remember, this is the first term, this is the second term. So you can probably tell what this is just by looking at it, but you don't want to let this mess with your head. So I want to start with the second term and then subtract off the first term. That's the order that you want to go in because this is talking about one term minus the previous term. So just making sure you've got the signs right because I know sometimes negatives can mess with your head. So this then turns into negative 5 plus 7, right? And so this equals 2. So my difference, my common difference in this case would just be equal to 2. And we can see that every time I add 2, I go to the next term. So what I want to do is I just want to find the first 5 terms of each sequence. So first I will just tell you the first term is 3. And the common difference is negative 2. This is enough information to determine the first terms of the sequence. So the first term is 3, and then if the common difference is negative 2, then I'm just going to subtract negative 2. So for my second term, the next term will be 1. So what's the next term after that? Well, I take 1 minus 2, and that's going to equal now negative 1. What about the next term? Then I take negative 1 minus 2, that equals negative 3. And then you can probably tell, right, that the last term will equal negative 5. So there are the first 5 terms of the sequence. Okay, so let's do another one. So now my first term is going to be negative 5, and the common difference is 7. So I want to recommend that you just pause here for a second and you write out the 5 terms, and then hit play when you're ready. So we've got the first term, so let's move on to the next term. So if I just add 7 to this, then this is going to be 2. If I add 7 to this again, we get 9. So I just keep adding 7. And then I get to my fifth term, and that's 22. So there are the first 5 terms in the sequence. The first one was given to us. So how do we find the nth term of an arithmetic sequence? So meaning, what if I want to find not the first 5 terms, but like what if I want to find a much bigger term? Or what if I just want to have like a theoretical nth term? Well, to do that, we have actually a very nice simple formula. A sub n equals a sub 1 plus n minus 1 times d. So I'll show you how to use this in a second. So, okay, let's say that I have the example. So I want to determine a sub 11, so the 11th term, and a sub n for this arithmetic sequence. Okay, so the thing to notice in this sequence is that the first term is what? The first term is negative 2. And then if I want to find the common difference, I can take 2 minus negative 2, which is going to be 2 plus 2, which equals 4. So we have a common difference of 4. So now I can use this formula that we just saw. So if I want to find the 11th term, so let's think about this. I am going to take this 11 minus 1 and multiply that by the common difference of 4. So here's the calculation that I need to work out. Oops, and I meant to write negative 2 here, sorry. So here's the common difference. And here's everything that I need to run out in this calculation. So then this is just going to be negative 2 plus 40, and so that equals 38. So 38 would be the 11th term in this sequence. And then what if I wanted to just know what's the general nth term? Well, we already have the formula here for that. And you know, if you wanted to distribute this, so if you just want to fill this in as best as possible, so I put in negative 2 for the a sub 1. There's nothing I can do for the n minus 1 since we're just keeping it general, but I can fill in the difference. And I'm going to move that difference just to the front just because I like having a number in front better. And I can distribute this, right? So this will become now negative 2 plus 4n minus 4. So my a sub n, I'm running out of room here, sorry, will be 4n minus 6. That would be how you find the general nth term. Okay, so let's try this again. So for this one, we're just given 2 terms of the sequence. I think you have enough information here to figure this out, so I want to challenge you to try this one on your own and then hit play when you're ready. Okay, so first of all, we can find the common difference. So we've got to kind of think about this a little bit, I know. So if I take 16 minus 9, so that's 4th term minus the 3rd term. So that's equal to 7. Now, for that formula, remember we have a sub n equals a sub 1 plus n minus 1 times d. So you might have noticed in doing this, I don't have a sub 1. But we can probably figure this out now, right? Because we're not too far along in this sequence. So if a sub 3 is 9, so how can I move back to a sub 2? Well, I can just subtract 7, right? So normally, to get from one term to the next, you would add, but if you want to go backwards in the sequence, then you're just going to subtract it. So if I subtract 7 from this, I'll get 2, and then if I subtract 7 one more time, I get negative 5. So I can back my way into what a sub 1 is, and now I've got all the information I need to help finish this problem. So for the a sub n formula, I can plug in that negative 5, leave the n minus 1 alone, and then that common difference was 7. So now I can just simplify this. So this becomes negative 5 plus 7n minus 7. So I get that my a sub n is going to equal 7n minus 12. And then to find the 20th term in this sequence, so I'll take negative 5 plus 20 minus 1 times 7. And so if I just do the math on that, I get that the 20th term will be 128. Okay, so now we have kind of a challenging question here. I've been told that the 7th term in the sequence is 15 and the 14th term in the sequence is 35. So now I want to determine what is a sub 1. Well, I know this is kind of challenging. I think though that, you know, we've talked about a lot of things here. This is a little bit of creative problem solving. I think you should try this one on your own. See if you can figure it out. I think you know enough at this point to kind of be clever. Hit play if you're stuck or if you think you may have found it. Okay, so there's more than one way to kind of reason your way through this, but I will show you kind of the most efficient way. So to go from A7 to A14, that's 7 terms difference, right? So what's going to end up happening then is that I'm going to have 7 times D. Well, to get to A14, what happens is that I have A7 and then I will take 7 times whatever the common difference is. So that's kind of what's happening here. So we took the idea of that initial formula and now we've kind of modified it. So this is good because at least I can set up an algebra equation and solve this. So let's see, I've got negative 35 equals negative 15 plus 7d. Okay, so now if I go through and I solve this, so, 15. This will be negative 20 equals 7d. So you have kind of a nasty common difference in this case, but that's okay, we can deal with it. So this is the common difference. And now we can leverage this formula, the fact that a sub, let's see, why don't we use a sub 7? So what would it mean to be this formula? Well, I need a sub 1 plus n minus 1 times the common difference. So check this out. We actually have all of this information except for a sub 1. So if I plug in the known quantities, so I have negative 15 equals a sub 1 plus 7 minus 1, and then that common difference was negative 20 over 7. So now I just have an algebra equation, so I can figure out what a sub 1 is. So this becomes negative 15 equals a sub 1 plus 6 times negative 20 over 7. And so if I just try to leave that in fractional form, so this is minus 120 over 7. So then I can add 120 over 7 to both sides. And so I get that my a sub 1 must equal 15 over 7. So that was definitely kind of a tricky one. Okay, and so that's it for arithmetic sequences. So I'll catch you guys in the next video where we'll talk about arithmetic series.